Hello Year 11 and welcome to our fourth video here for number and surds. We're going to look at surds today, surds being the square root of some number, right? An irrational number if we can't simplify it. Now some of these we can. I can find the square root of 16, it's going to be plus or minus 4, and the square root of 7,225 is going to be 85, I'm pretty sure, or plus and minus 85. Consider this if you like. If x squared equals 16, then we could say that x squared minus 16 equals 0, and x plus 4, x minus 4 equals 0, therefore x equals plus or minus 4. Okay, and the same goes here with 85. Now, simplifying surds, knowing these things, these little rules we've got written down here, but most importantly, I suppose, is that the square root of a times the square root of b is the square root of the product of a and b. So that's the most important one. Following on from that, we can do some arithmetic with our surds. Now, root 14 times root 15 on 7, well, root 14 is root 2 times root 7, which means I can cancel that root 7, right, so I'm going to say this is root 2 by root 7 by root 15 over root 7 if we like. The root 7's cancel, I've got root 2 times root 15 equals the square root of 30. There's not much more I can do with that. If, however, I had a number like, I don't know, let's say 12, if I had root 12, we could rewrite root 12 as root 2 times root 6, which is not very helpful. But I could write it as root 4 times root 3. And that's different because root 4 can be simplified or reduced. Root 4 is 2. So root 12 we could express as 2 times root 3 or just 2 root 3. Let's look at an example to go with that. I've got root 20 here. Now root 20 is root 4 by root 5, which is 2 root 5. What we're looking for when we simplify these is a square factor. So a number that's a square, like 4, 9, 16, 25, and so on. Really, it's mostly the prime squares that we look hardest for. 4s, 9s, 25s, maybe 49s are going to get you through most of these. Right? We look for a square factor. I can sort of break that away and simplify that down to an integer. Now, here I have 3 surds being multiplied together. Root 6 being a 2 and a 3, 10 being a 2 and a 5, and 15 being a 3 and a 5. So this is going to be the same as, if we like, I'm going to take the 2 from here and here. So that's a root 2 times a root 2 gives me 2. I'm going to take the 3 from here and here. Oops. And the 5 from here and here, oops, and that's equal to 30. My pen's playing all sorts of games at the moment. That's equal to 30. I could just multiply them together and get 60 times 15 is going to be 900, root 900, and then work out the square root of 900 is 30. That'll work as well, but perhaps easier if we keep them as smaller numbers. If I expand this out, remembering the pattern here, perfect square, square the first is 9, plus twice their product, so plus 6 root 2, plus square the last is 2, so this is 11 plus 6 root 2. And over here, we'll need to be a bit more careful. It'll be a little bit slower to do this. 2 by 4 is 8, 2 by negative root 3 is minus 2 root 3. 5 root 6 by 4 is 20 root 6, and 5 root 6 by root 3 is, if we like, minus 5 root 18. But when I see that root 18, I need to see straight away, that is, right, root 18 is root 2 times root 3. Sorry, is root 2 times root 9, 9 being a square number. Now we'll just collect these bits together. I'm going to have, so we said that this here is going to be the same as the root 18 itself is 3 root 2, So it's negative 15 root 2. So 8 minus 2, it's not working again, minus 2 root 3 plus 20 root 6 minus 15 root 2. And I can't do any more with that, just stays there. Okay, so that's the start of some of this arithmetic with surds. Remember to look for those square factors. That's a really important thing. Looking for the square factors of 4, 9, let's say 25, and the main things to be looking for there. Rightio, if you've got any questions, please jot them down, ask me in class, I'll see you then.